All right, 7:30, so we'll go ahead and get started, knock this out real fast. Really not a lot to cover today. It's actually pretty easy for this week's material. Now, this week's material is about exceptions. So what are exceptions? Exceptions are, they're kind of like errors that happen in your program, but not necessarily errors in your code. It usually results with some kind of external forces acting on your program, be it user input, or maybe you try to open a file but the file doesn't exist. Those aren't necessarily code errors, but they're errors that could arise when something unexpected happens, and that's what we call an exception. So let's take a look at some exceptions. So let's ask the user for some input, because user input is a lot of times where exceptions can occur. So let's make a scanner equals new scanner for system.in. That should be right. And then we'll have string s is equal to scanner.next. Was it like next line? Yeah, just next. Okay. So have a scanner. We'll print out enter an integer, and then we'll get the integer, and then the scanner returns a string, but let's convert it to an integer, because we're telling the user enter an integer, so let's convert it to an integer. So int a is equal to, there's a method we can use called integer dot parse int, and we give it the string, and it gives us the integer back. And then print ln, you entered a. So a very simple program. We make a scanner to be what the user types in at the keyboard. We're going to tell the user enter an integer. We're going to get the integer. We're going to get what is typed in at the keyboard. We're going to convert that to an integer with this integer.parseInt, and then we're going to print it out, right? Let's run it. And here we go. Down here it is. Enter an integer. Okay, 23, and it parsed it. It says you entered 23. That's right. Okay, nothing happened. Nothing went wrong. But what if we type in a string? It's going to try to take this string and parse it to an integer, right? What happens? We get what we call an exception. And here it is. Our program basically crashed, and it says there's an exception in thread. It's a number format exception for the input string ASDF. And it tells you, this is the stack trace for where it exists. It's probably beyond the scope of this class, but you see right here, the last line at myexceptions.java, line 12. So if we go to line 12, it's this line right here, and we can see that when it tried to parse that integer, this string was ASDF, and that doesn't parse to an integer, right? And so we get this number format exception. But the thing is, our program crashed, right? That's bad. We don't want our program to crash. So it crashed if it was a string. What if we type in a floating point number? Same thing. Our program crashes because the string 3.14 cannot be parsed to an integer. It could be parsed to a float, or it could be parsed to a double. Meaning, if we have a float here, we can do float.parseFloat s. Let's run that. So now if we do 3.14, it works fine, because the string 3.14, that can be parsed to a float. If we type in an integer, that can also be parsed, because the integer 23 is the float 23.0, right? So that works. But again, when we type in a string, that string cannot be parsed to a float. And so we get this exception and our program crashes. Okay. So these parsing floats or parsing integers, they're not the only exceptions that can happen. Let's say if you accidentally divide by 0, I'm pretty sure that creates an exception. So let's get the integer. Integer A is integer.parseInt s. And for some reason you wanted to do the math, 100 divided by A. And then we're going to print out the answer. You know, maybe you made some kind of calculator or math program. So you ask the user to input an integer. They input the integer. We parse it to an int. And then we do, you know, this 100 divided by this integer they input. And then we're going to print it out. You know, so if we type in the integer 2, everything's fine. You know, the answer is 50 because that's 100 divided by 2. Well, if we type in 0, we get an exception. There's an exception. Divide by 0 at, you know, this Java file, line 14. So right here is the exception, a divide by 0 exception. And so, you know, this isn't necessarily a problem in our code. It's that the user typed in a 0 to divide by, and that's wrong. You know, mathematically, you can't divide by 0. And so it's an exception to where something unexpected happened, even though there's not an error in our code. You could also get it like, you know, when we did our scanner, if we did the system.in, well, let's say we had a different input stream and it was just null. So if we try to do a scanner on that input stream, try to run it, again, we get an exception, null pointer exception, you know, at this line 9 right here, the null pointer exception. So there are lots of different exceptions. These are just a few examples, but there are many, many, many exceptions out there. And the way you can tell if something's going to be an exception, like I said, this exception was on line 9. If we go and look at the documentation for scanner, I'm not going to pull it up right now, but if we look at the documentation for scanner, we will see that if this value is null, then this constructor will give us this null pointer exception. Okay. But let's not get that exception right now. Let's stay with this example right here where we divide by 0. Okay. Actually, I like the example better to where we're just parsing an int. So right here, you know, we'll do the scanner from the keyboard, from the system. We're going to print out enter an integer. We're going to scan the integer. We're going to parse it. Integer A equals integer.parseInt. And then we're just going to print it out. A is, you know, whatever that value is. So I've already shown that, you know, if you type in a string here, or if you type in a float, then you get an exception right here at the parse int, because you can't take a float and change it into an int. You can't parse it into an int. You can't take a word and parse it into an int. It doesn't work. It gives you an exception. And the key thing is it causes your program to crash. Well, crashing programs are a big deal. You don't want your program to crash really under any circumstances that you can help. So what can we do? We have what we call a try and catch block. And it looks like this. There we go. That's what we call a try and a catch block. Let's throw that in there too. Okay, so what are we doing here? So we're still getting the scanner, but all of that same work where we tell them to input an integer, we get this what they type in at the keyboard, we parse it to an int, and we print it out. It's all inside this try block. And what does that mean? What we're saying is something in here might cause an exception. Not that it definitely caused an exception, but it might call an exception. Let's put some more prints in here. Start of try, just so we can see where we're at in the program as it runs. Say that's the start of the try. This is the end of try. It's the start of catch. It's the end of catch. This is after catch, and then we'll have a before try, just so we can see in the printouts, we can kind of follow along where the program is at all time. Before try. Okay, so what's going to happen here with our program? Here we're going to make this scanner. We're going to print out before the try. Then we're going to start this try block. We're going to do, it's going to print start of try. Then it's going to do all this code. Then it'll do end of try. If there is no exception. So what happens here, the program will start executing all this code. If all of this is successful, if there is no exception, then it will skip the try, it will skip the catch, and then it'll go to after the catch. As it's executing this, if there is an exception, and as we've seen, this right here is the line that the exception will occur on. So if there is an exception right here, then it will stop executing the try, meaning it will not get to these, but it will jump immediately to the catch. So what we should see here is if we type in a valid number, we should see before try, start try, then we'll do this code, then we'll see end of try, and then it'll jump down here to the after the catch. If we do type in an invalid number, if we just type in a word, we will get before try, start of try, we'll get enter an integer, it'll do this scanner next, it'll get to this line 17, an exception will occur, and then it will jump down here to the catch. And what do we want to do with the catch? What you want to do, you can do any other code you want to do in the catch. For us, let's just tell the user you input an invalid integer. We'll tell the user that they input an invalid integer. So let's run this. And you see there, we got the before try, we got the start of try. Now we're at input an integer. Let's input a valid integer. Put 11. There we go. That was that. We got the parse. Then we got the A is 11. Then we got the end of the try. And then we got the after catch. Notice we skipped all of this exception, all of this catch stuff, right? Let's enter in something invalid. 3.14. That is not an integer. As you can see, we got the before try, we got the start of the try, we got the input an integer, we did the scanner, we got here and tried to parse the int, but an exception occurred, so it jumps down here, and we get start of catch, you input an invalid integer, end of catch, and then after catch. Okay. We could also do, instead of just input end of integer, we could also print, the exception is this variable e. So we can say e.toString so we can see what the exception is. We run this. Again, if we type in an invalid number, then we get, we get what's inside of that catch. You get an you input an invalid integer, and this was the exception. Okay. Exceptions are really good for doing just kind of what we're doing here, is for catching invalid input. It's for determining invalid input. So let's imagine we're making a calculator, and let's just say we're going to add two numbers together. So we need the user to input two numbers, right? We need a num1, we need a num2, right? So how can we get those two numbers, but making sure they input valid numbers? Well, we can do it just like this. Let's get rid of these extra print statements. Input an integer, we scanner it, and this will be num1. Then we'll get, excuse me, here we go. There's one integer. Let's get the second integer. And we get the sum is, the two numbers added together. Sum is sum, right? Get rid of these and leave it right there. Okay, so let's look at what we got. So like I said, we're just making like a little program here to have the user type in two numbers, and then we're going to add the numbers together. So num1, num2 is going to be what they type in. So we're saying enter an integer. We scan it from the keyboard. We parse it into an integer. We get the second number. Enter an integer, scan it from the keyboard, parse it into an integer. We're going to do the sum of those two numbers, and then we print out the sum of those two numbers, right? So if we run this, of course, if we enter two valid numbers, it works. It says the sum is 5. Let's put an extra space in there. Sum is 5, right? If we enter an invalid number, actually, let's do that again. 2 plus 3 gives us the value 5. If we comment out the try and the catch, meaning it doesn't exist anymore, if we try to do this without the exceptions, our program crashes. We don't want our program to crash, so we want to throw in these tries and these catches to catch the exception so our program doesn't crash. Now, if we enter invalid input, our program doesn't crash anymore. It says you input an invalid integer, and that is the exception, because in the catch, that's exactly what we're printing out right there. So how can we force it to be valid input? Well, what if we put this here, a while true loop here? Actually, let's look at something better than that. Let's make a method. This helps expand our Java knowledge. Let's make a method, private void int static int get int from keyboard. Let's just call that a method. And this method will get an integer from the keyboard, right? So let's put this text down here, and then we'll return the num. Int num, enter the scanner. What was it? New scanner system.in. Oops, put this up here. What I'm doing down here is just putting in some code to get an integer from the keyboard. Yep, that looks right, right? So we're making a scanner for the keyboard. We're saying enter an integer. We're going to scan that keyboard input into the string. We're going to parse parse int into this num, and then we're going to return num. So this int right here, this method get int from keyboard, does just that. It gets an int from the keyboard. Let's try it out to make sure it works. So we're going to say num1 is get int from keyboard, right? Num2 is get int from keyboard, right? The sum is num1 plus num2, and then we'll print sum is the sum. Okay. So notice right now I don't have any kind of try, any kind of catch. So if I type in something wrong, it's going to crash my program, right? So here we go. Enter an integer through, enter an integer 3, and it works just fine if I don't type in something invalid, right? But as soon as I type in something invalid, type in this, crashes my program, right? So what we can do here, let's make sure that this returns an integer. So if we do a while true, while true means this loops forever. It will never end unless we do a break or we do a return, right? So what we need to do, we need to put our try and our catch in here around this code, because this is the code that might have the exception. We've already talked about it's going to be, if there's an exception, it's going to be right here at this parse int. That's what's going to cause the exception if there is one. So if there's an exception, it'll go to the catch. So let's tell the user in error invalid input. So what's going to happen here? So we'll go here, we'll get the input from the keyboard. If it is a valid input, then it'll just get here to the return num, and it'll return out of the method. It'll return back up here. However, if there is an exception, it'll come down to the catch. It'll say error invalid input. But since there's no return, it'll go back up to the top of the loop, and it'll do this try and catch again. Let's watch it in action. So let's do valid input. 5 and 6. It works just fine. The sum is 11. If we type in invalid input, error invalid input, enter an integer. Error invalid input, enter an integer. 3.14 invalid input, right? So you type in a valid input. Well, now it's asking for it again, but that's because we're here at the second one now. All this error invalid input was from this first call to the method. Eventually, we entered valid input. It returned, and so now it's getting the second one. So with the second one, same thing. We type in invalid input, it tells us invalid input. But when we finally type in the right number, it gives us the sum. That's because the first one finally got 5 as a valid input, and then it finally got 6 as a valid input, and now adds those two together and it says the sum is 11. So as you can see, even though I typed in something that does not parse to an int, normally it would cause an exception here, and actually it did cause an exception, but we catch the exception and we do something with it. If there's an exception and you don't catch it, then that's when it will crash your program. And crashing your program is bad. Okay. We can also do exceptions manually. Let's see what that looks like. So let's leave all this code in place. Let's run it. Let me show you something. If I enter a 0 here, a 0 is fine because a 0 is a valid integer, right? And we put 5 there, it's fine. It sums them up to be, 0 plus 5 is 5, right? Let's say if I input negative number, oops, did not mean to type that there. If I input negative numbers, That's fine as well, because negative numbers are integers. That works just fine. But let's say we do not want the program to be negative numbers. We just don't want to do negative numbers. How can we prevent it from doing negative numbers? There's actually a couple ways. We could say here, if the number they entered is less than 0, then do something, right? We could do that. Or we could do this: throw new exception, invalid, or a number cannot be less than 0. So what's going to happen here? And then here, let's do let's print out what the exception is. You got toString. So say if num is less than 0, we're going to throw this exception. Okay. So what's going to happen here? Let's run it and then we'll talk about it. So if I use normal numbers, normal positive numbers, no problem, works just fine, right? If I use something that's not an integer, then we get the catch here, because it's this exception. It can't parse it to an int, and so it'll say, we catch it here: error invalid input and number format exception for input string 3.14. What that's saying is I typed in 3.14. I tried to parse it as an int, but I can't. Okay. What happens if we type in a 0? A 0 works just fine, because a 0 does parse as an int, and then 0 less than 0, that's false. So it does not do that, and then just returns the num. Well, let's see what happens when we put in a negative number. So put in 6, minus 6. Look what we get. We get error, invalid input, exception, number cannot be less than 0. That's exactly what we have right here. So when we did this parsing of an int, we decided ourselves, the programmer decided, I don't want it to be a negative number. So I check, is it a negative number? If it is a negative number, then I'm just going to throw this exception. And I'm throwing the exception because I know I'm going to catch it right here and say it's an invalid input and do it all over again. Why didn't I do I could do something like this, actually, if it's greater than or equal to num, then I can just return the num. And then here, if it gets here, then the number is negative, right? Because if the number is positive or 0, it's just going to return it. So if it gets here, it's negative. So I could print here, num is negative. That's basically going to have, it's going to have the same effect. You see 6 minus 6, it says num is negative, and it'll keep going until you type in a positive number, right? So you can do it that way, but I think it looks cleaner if you would do it like this. You would check for the exception. If the number is less than 0, it's an exception to us. So we can throw the new exception, no negative values. And then in here is where we do all the work if it's invalid input. So it'll get to this catch if it's letters, if it's a floating number, or if it's a negative number. So in here, we can do all the work at one time. We don't have to repeat the work. So that's how we can throw exceptions manually. Last thing we'll mention is we can have our own exception types. So let's make our own exception. Let's make it a class my, let's see, we'll call it a, we'll actually kind of replicate what we got here. We'll call it a negative exception. It can extend exception. And really, that's all you have to do to make your own exception. Now you can have your own methods and additional constructors and stuff like that in here. But this is enough bare minimum to make it work. Yeah, there we go. So right here, instead of throwing a new exception and then putting this, we could throw a new negative exception. So now when we run it, if we put in a negative number, then look at what the exception is. Here where we print out, it's this exception E, and then we're just doing E.toString. It's right here. It's saying it's a negative exception. So that's how we can make our own exceptions. And these can be for anything you want. Let's say, silly example, let's say it's a color exception. Let's delete out all this stuff that we're not. Let's have a try and a catch. And when there's an exception, I'm just going to print out the exception, E.toString, okay? Just to show you, you can have an exception for anything. So let's have a color, C equals color.red. Let's just put it in here inside the try. Let's say we don't want any green colors. So we can say if C equals color.green, we don't want green colors. So let's throw a new color exception. Okay, so let's run it. We're actually not going to get any print out. There's no print out. That's because we didn't print anything in here. The only time we print is if there's an exception. But there is no exception because, we're making the color red. If the color is green, we're going to say it's an exception, but it's not. Let's say the color is green. For some reason, we don't like green. So now when we run it, we do get the exception printout, and the exception type is this color exception. So that's an example. You can have an exception for whatever you can dream of. You can have a money exception. Imagine you have a bank account, and if the balance is less than 0, you throw a money exception. That's how you can do a money exception. Okay. And that is all of the material for this week. It's all about exceptions. There's really just these simple examples that I've went through here with you. So I'll open it up to any questions. All right, I see no questions. I will get this video loaded up and post it online a little bit later this evening. All right, have a good night.